In this video, I would like to quickly talk about the concepts in 11.9, Trapezium Rule. So back in the days when everything is nice and easy in GCSE, when we would like to find the area under the curve, without integration, we'll simply find the area by using some simple shapes. For instance, using a triangle, rectangle, or trapezium. So in the first example here, if I would like to find the area in between -1 to 1 of 4 minus x squared, I could chunk this up into two separate trapezium and work it out. So it will kind of look like this, where you could recognize the length, the height of the trapezium at x equals to -1, 0, and 1. And then you could use the formula for the trapezium to work it out, which is the sum of the parallel lengths multiplied through by the width, which is 1 divided by 2. And in this case, it will be the same shape because it is symmetrical. So you could add this up to get 7. So what is new in 11.9? So we would like to generalize a formula because later on we're going to work with 5 to 6 strips. So we'd like to actually get a formula so that it will help us to quickly find the area using trapeziums. So we'll start again with this same diagram. I'll just hide the y-axis as if we don't know it. And if I would like to find this area, so same case, with these trapezium, I need to know the dimension of it. So the length of these purple lines, since I don't have the y-axis, I can only use letters. So at x equals -1, the height, I'll just refer as y0. The second one, when x is 0, so it is a different height, so I'll call it y1. And at x equals to 1, similarly, I'll just call it y2. So if I'm going to work out the area of these two trapezium, so for the first one, that will be a half multiplied by the sum of the parallel lengths, y0 plus y1, multiplied by the width, which is 1. And same case for the second one, a half times y1 plus y2 multiplied by 1. So I could factor out what they have in common, which is a half. And I'll keep the 1 as well so that it will help us to identify what is going on next. So that will be a half times 1 times y0 plus y1 plus y1 plus y2, which will give me a half times 1 y0 plus 2y1 plus y2. So you could see that if I'm just going to generalize the idea with letters, then I'll end up inside a square bracket y0 plus 2y1 plus y2. But how does the general formula looks like in terms of m? So we'll just do this process one more time, and let's see if you guys can guess it. So in this case, in fact, I want to find the area not only from -1 to 1, I want to find it from -1 to 2. So in this case, I'm going to add another shape there so that it can help us out a little bit. So in this case, you could see that we will have, again, several shapes. One additional shape this time is just a triangle. And so let's just work out the area. So for the first one, that will be a half times 1 times y0 plus y1. The second one, a half multiplied by 1, y1 plus y2. Then the last one is just the base times height, which is a half of 1 times y2. And since y3 is 0, so it doesn't matter if I add y3 here or not. Okay, but in the case where, since we're using trapezium, So I just assume that y3 is still a number, and then so we could formulate the area using this format. So if I once again factor out a half and 1, you could see that within the square bracket we'll have y0 plus 2y1 plus 2y2 plus y3. So you could see that if we are using trapezium rule, so the first one we got y0 plus 2y1 plus y2 inside the square bracket, and in this case y0 plus y3, the endpoints, plus 2 loss of y1 plus y2, the ones in the middle. So if you could guess the trapezium rule formula at this point, well done. So let me tell you what that is actually. So the trapezium rule is actually given as a half times h, which stands for the width of each strip. So the width of each strip is 1, so that will be h, and then times it by the endpoint y0 plus where we end with, let's say y2, plus 2 lots of what is in between, in this case y1, and in the next case that will be y1 and y2. So you could see that y0 plus y3, the endpoints, plus 2 lots of y values in between. So that will be the formula for the trapezium rule. So let's have an example with how we could find the area using trapezium rule and using the formula given, which is in this case here. If I would like to find the area of R from 0 to power of 3, they have provided us a table to fill in. So I would like to find a corresponding y value when x is power of 6 and power of 4, which means that you could find a value that I just unselected by putting in x as power of 6 into sec. So that will be sec of power of 6. That is sec of power of 4, which will give me 1.414. And then I could just use the formula. So that will be a half multiplied by the width of each strip, which could be found by taking the difference consecutively between the consecutive numbers. So you could see that it is pi over 12 when you take differences between each consecutive pair of numbers. So B, if I would like to find the area, I could just do a half multiplied by the width, which is pi over 12, multiplied by the endpoints, 1 plus 2, the y value, plus 2 times the values in between, which is 1.35 plus 1.155 plus 1.414. And then you could use it to find the area. It's just like that. And then so for part C, if I would like to justify with a reason whether our area is going to be an underestimate, our answer here is an overestimate or underestimate. It will be based on the shape of the graph. Don't worry, they will provide that for you. Where if you just use one trapezium, for example, connecting from 0 to power of 3, you could see that will connect above the curve. So that's why that trapezium will give you a overestimate to our answer. So that's why for C, you could just say that this is overestimate. And that is essentially 11.9 for you. And it's just that there are 2 reminders that you need to be careful with. The first one is how to use this formula. So remember, h is the width of each strip. You can find it by either using the formula, which is h. The width is b. The b minus a. The differences between between the endpoints divided by how many strips they want. Because sometimes they do just tell you, I just want to find the area with 6 strips. Then you need to work out the width of each strip. And once you have done that, form a table, and then just add on the width of each strip until you reach to the end of the upper bound, and then find the y value. Once you have done that, throw it into the formula. Don't worry, they will provide that for you. And then once you got the answer, then that will pretty much it. And the second thing that you need to be careful with is they normally ask if your answer provided in B is underestimate or overestimate. So it really depends on the shape. So if your shape is like that, our first example to start with, you could see that you will always have an underestimate, because when you join up 2 points anywhere on this curve, it will be always underneath the graph. So that will be the case where you will underestimate, whereas if it is the opposite, and this is a convex curve, where if you just join up any points in between, you could see that that will give me an overestimate of the area under the graph. So that is all I need to tell you in 11.9. Thank you.